Section 5.8 is a large section. It is real-life modeling of exponential and logarithmic equations. And there's no formulas on your formula sheet for any of these equations or formulas that are going to be up there because they will always give them to you in the question, which means that your exam is completely open to any type of real-life word problem involving exponents or logarithms, and you have to be able to solve it. So what we do is we look at a bunch of situations that use exponential functions and a bunch of situations that use logarithmic functions, and hopefully give you a wide array of formulas that you could use that have been on exams so that when you get to any formula on the exam, you're able to solve it. So some examples of where logarithms and exponential functions are used. We've got things that have exponential growth, like population. Populations usually grow exponentially. They double every so often. Compound interest. We've already talked a little bit about compound interest earlier, but we just solved things with our calculator. Now that we have logarithms, we can solve it in an algebraic way and not a graphical way. Decibels. Did you know for sound, the difference between something that's 100 decibels and 110 decibels to 120 decibels? Each time you go up in your decibels, it is becoming quite a bit louder. 100 to 110, I think, is 10 times louder, and then 110 to 120 is another 10 times louder. And so it is exponential in that way. Same thing with earthquakes. A 6 compared to a 7. A 7 is 10 times more intense than a 6. And an 8 is 10 times more intense than a 7. So when you compare an 8 to a 6, it's 100 times more intense. When you compare a 9 to a 6, it's 1,000 times more intense. And so they probably don't even mention earthquakes that are like at a 5. Because even though for us in Manitoba, if you experienced an earthquake at a 5, you'd be like, whoa. But they'd be like, oh, these happen all the time. And in chemistry, your pH scale for how acidic something is also logarithmic and shows exponential growth. And there's also some things that have exponential decay. You've got bacteria decaying, you've got half-life of radioactive substances, the amount of drug in your body, for a lot of drugs, your body gets rid of a certain percentage of the drug in a certain amount of time. So I don't know if you've ever had a headache. And if you've ever had a headache, I don't know if you've ever taken Tylenol or something for it, but you look on the bottle and they give you instructions. Take 1 or 2 tablets every 4 hours. Now, what most likely is happening, and I'll make it a simplified situation. Let's say you take 2 500 milligram tablets, which would be 1,000 milligrams. And in that time that they gave you, your body gets rid of half of the drug. So you take 1,000 milligrams of Tylenol, the Tylenol starts to work, and your headache's not so bad. But 4 hours later, your body has used up half of that Tylenol, and now there's 500 milligrams still in your body. And if you still have a headache, what do? You take 2 more. But now how much is in your body? 1,500 milligrams of Tylenol. And so you're feeling pretty good, but then 4 hours later, your body again gets rid of half of it. Now you have 750 milligrams of Tylenol still in your body. And you take 2 more. Now you have 1,750 milligrams of Tylenol in your body. 4 hours later, your body gets rid of half of it. So now we're at 875. You take 2 more. This is probably something worse than a headache. You should go to the doctor. But if you keep doing that, it's designed to do something. Eventually, you will get to the point where after 4 hours, your body has close to 1,000 milligrams already in it. And when you take 1,000 more, you just stay at that amount. Now, you might say, well, if it eventually gets to the point where I have 2,000 milligrams in my body and my body's getting rid of half of it and it's just staying at that amount, why didn't I just take 4 pills to begin with? Well, that's usually not good for your system to get that much of a drug right away. But if you take it over a period of time and slowly build up the amount of drug in your body, it is less harsh to your system. Okay? Then your headache's gone and you're like, good, I'll stop. But after 4 hours, you still have 1,000 milligrams because it only cuts half. And then after 4 hours, you still have 500. And then after 4 hours, you still have 250. And then after 4 hours, you still have 125. And then 62.5, and then 31.25, and so on, all the way down. And it gives you an idea, because your body only eliminates a portion, gives you an idea of how they can do drug tests in the Olympics. And they can figure out, if you have this amount in your body right now, at race time, you would have had this amount. And that would have been illegal. Because your body doesn't get rid of it completely. Now, eventually, when you keep cutting something in half, it gets so close to 0 that you could basically say it's gone. But that's part of how they can use science to figure out if you had a drug in your body when you were at that race or something. So the first thing we're going to look at is compound interest. And we've seen this formula before in our notes, but this is how you would get it on a question on a test. They would say, using the compound interest formula, blah, and they would tell you each of the things and what they stand for. That A is the amount, the final amount, P is the principal, N is the number of compounding periods per year, R is the rate, the interest rate as a decimal, and T is time in years. Now that they've told you all of those things, when you get a question, you are supposed to be able to figure out where to plug these things in. Determine the final value of $500 after 10 years if it's invested at a rate of 2.25% and compounded monthly. So we have to take this and say, well, of all of those things, I want to find the final value, so I want to find A. The principal, the amount that I started with, was $500. Here, I'll just write the formula up there, just so we can reference it as we go. So then I'm going to have 1 plus the interest rate is R as a decimal, so this is 2.25%. I need to change that to a decimal. The number of compounding periods monthly is how many times in a year? 12 times in a year. To the 12t. Oh, I shouldn't have put t because we knew it happens in 10 years. Since everything is on the right-hand side of your formula, you could just type this entire thing into your calculator at once. And I would suggest typing this exactly as you see it, using your fraction button and exponent buttons as you go. So for typing this in, 500 bracket 1 plus, use the fraction button, 0.0225 divided by 12, close your bracket, to your exponent of 12 times 10. I want to make sure that you're able to get $626. So that means you had $500 and you've made $126 of interest, which is exciting. Had you done that 4 years ago, then when you graduate, you'd have an extra $126 to spend on your math teacher. Nice. Unfortunate for me, I'm guessing that many of you did not do that 4 years ago. Oh, 10 years ago, yeah. Even worse. 10 years ago. You were 6. So I think your parents would have been worried if you would have said to them, you know what, I've been reading about compound interest. And I'm wondering if you could give me $500. All right, here's one. I'm just going to show you the answers for it. We're going to skip over that one quickly. Calculate the final value of $200 compounded semi-annually. How many times a year is semi-annually? Twice a year. 5 years at a rate of 3%. Once again, it's one that you can just plug things into your calculator. Now in the red there, if you have an older calculator and you have 2 things in your exponent, you will need to put brackets around those. So our first couple of examples, there's going to be logs in this one. Our first couple of examples have just been like, plug it into your calculator, life is easy, okay? But this one says calculate the time. And time is t, and t is in your exponent, so you're going to need logarithms to solve it. Because anytime you're solving for x in an exponent, unless you can get the bases the same, you're going to need to use logarithms. So if we put everything into our formula, and again, I'll put the formula there and plug everything in. We have an investment of $30. So we know the principal is 30. That's what we started with. What can we put in for the amount? 60. And then 1 plus the interest rate is 7%. Compounded monthly, 12 times a year, 12, and we want to solve for t. Now, one thing that I'm going to get you to do with these ones to make your log laws easier is instead of taking the log of both sides right away, I'm going to get you to simplify. What could we divide both sides to get the power all by itself? Can you see you could divide both sides by 30? If I divide both sides by 30, my equation becomes, and this is fascinating, but I'll talk about the fascinating part at the end. So if I divide both sides by 30, then I get 2 equals that, and now I can use my log laws and take the log of both sides. I've got a single power. This side will be log of 2. This side will be log of 1 plus 0.07 divided by 12. And it'll be to an exponent. But since that exponent is the whole thing, can you see that you could bring that 12t out in front? I want to get t by itself. To do that, I need to divide by 12 and log 1 plus 0.07 divided by 12 on both sides. That will get me t is log of 2 over 12 log 1 plus 0.07 divided by 12. Again, I want to type this all into my calculator exactly as I see it. So I'll get my fraction button ready. On the top, I have log 2. On the bottom, I have 12 log 1 plus Fraction button again. 0.07 divided by 12. Close my bracket. Push enter, and I get 9.93. I'm going to store this as x. And because it's an exponential equation, you can always check your answer. So if we look back to our original question, my right-hand side was 30. Bracket 1 plus 0.07 divided by 12. Bracket 2. Oops, I forgot the 12. 12. To the 12, and I stored my answer as x. If we did it right, it should come out to be 60, right? Oh. What didn't I type in? The 1. Second insert, a 1. Okay. Yes, 60. So we know we've got it right at 9.93. Make sure 9.931. Did you know on your final exam that you always have to round 9.931, and it's in years, so we have to write the units. You have to round to 3 decimal places and write the units. 9.931 years. So in about 10 years, this investment will double. Oh. Now, interesting things in this equation. First of all, let's say he didn't have $30. Let's say he had, because 10 years, if you had $30, 10 years later you have $60, are you going to be doing cartwheels down the street? No. But let's say you had $3 million. How long is it going to take to double to get $6 million? Is it going to take a lot longer because it's going to go like from 3 million to 6 million, a lot longer? Well, I would have to put in 3 million here and 6 million here. What happens when I simplify? It's exactly the same. So if you had $3 million, 10 years later you look in your bank account, you have $6 million, I might cartwheel a little bit if I found out I had $3 million more. Okay? Same thing. If you had 3 nickels, 10 years later, you will have 6 nickels, and you won't be doing any cartwheels. Sometimes in these equations, they don't tell you how much money they have. They just say, how long will it take to double? And you can make up any number you want. 17 billion. Yeah, so I just need to convince a bank to give me $17 billion, and I'll say, I'll give it back to you in 10 years. Like, what's the big deal? But none of them have said yes yet.